Welcome to Unit 4, Lesson 11, Introducing the Number I Practice Problems. Okay, which point represents the complex number -3 plus 2i? Well, if we start at the origin, we go back 3 and up 2. That's the point A. Okay, match each expression to an equivalent expression. So 2i times 8 equals 16i. 16i goes with 4. Okay. I cubed, as we saw on the page before, is negative I. So this is negative 16i. And that goes with 3. 2i to the fourth. 2 to the fourth times I to the fourth equals 16 times 1, which is 16. So C goes with 2. And then 2i times 8i is 16i squared. I squared equals -1, so this becomes 16 times -1, which is -16. Oh, I meant to do that in red. So D goes up here. So now, what you're going to have to learn to do, whenever you're dealing with powers of I to the 0 equals 1. I to the first power equals the square root of -1. I squared equals -1 because this is the real number line and this is imaginary up here. Okay, and then I to the fourth is I cubed is the last of the original i's, and I cubed is equal to -i. And then we come back around. After we hit 0, we hit I to the fourth power. Then we hit I to the fifth. And then I to the sixth. And then I to the seventh. And you just keep going around a circle until you match your exponent. We're going to deal with that math. But every time you see this, draw this I to the 0 to the left, I to the first power up top, I squared to the left, and I cubed to the bottom. And we just keep going around in a circle. Okay, Diego squared a number and got 4. Andre squared a different number and got 4. What number were the ones that Diego and Andre squared? So obviously, the square root of 4 is 2, and Andre squared -2. Now, Jada and Elena are coming around, and they're squaring 2 different numbers. What were the numbers that Jada squared 2i, and Elena squared -2i. So it works just like positive square roots, but instead of the number, you get I. Find all complex solutions to each equation. Okay, so for A, just take the square root. A equals 1 and -1. But I think they just want us to deal with the positive. So let's just leave it with the positive root. The square root of B squared. B equals the square root of 13. Or the opposite of 13, or -13, negative root 13. So now, when we square C, you separate this into -1 times 9. C will equal the square root of 9 is 3. The square root of -1 is I. But you could get -3i. And then finally, when we square root D, this separates into -1 times 5. And then D will be I root 5 or -I root 5. Okay, let's practice some old stuff from the last test. Okay, to get rid of a cube, you have to cube the whole thing. When you cube something, it gets rid of a cube root. All that pops out is the bottom. 4 cubed is 64. You subtract 2, and A equals 62. 62 plus 2 is 64. The cube root of 64 is 4, so it's true. Okay. The minus 5 is not under the radical sign, so get rid of it. So the cube root of b equals 8. We have to cube both sides, and then b equals 512. Add 14 to both sides. The cube root of c minus 1 is equal to 10. When the cube both sides, the cube root of c minus 1 equals 1,000. Oh, I'm sorry. Once you cubed it, the cube root goes away. I'm sorry, I didn't mean to write that. Once you cube it, the cube root goes away. And now we have to add 1. C equals 1001. Okay, explain that how you know that the square root of -1 is not a -1 number. Because there's no number you can multiply to get the square root of -1. Because the negative times a negative is a positive. So, I don't know how else to explain it. Just the square root of -1 equals I. If I was to square it, the square root of -1, the bottom pops out and you get I squared as that. And that doesn't make any sense because if you take the root of 1, you get +1 and you get -1. It can't be both at the same time.